All right, Trig, welcome to a little notes video for Friday, April 25th, 2025. All right, this is a section 9-1 review. Guys, look online. You don't have any due dates for a while, okay? We might have missed section 9-1 for various little field trips or other things last, I guess now 2 weeks ago. So here's a little review. Given g of x is equal to 1/8 to the x power, find g of 2/3. So we have 1/8 to the 2/3 power. So here's what we're doing. We're going to take the third root of 1/8, which is actually 1/2, and then we're going to square it. So what is 1/2 squared? It is a quarter. Yes, your calculator can handle that, but again, some of you guys are going to go to colleges that will not allow that calculator in class. So how do we do this by hand? 1/8 to the negative second power. Okay, anytime you have a negative power and a fraction's involved, you want to flip the fraction and give it the positive power. So it is 8 to the second, which is 64. Again, check that with your calculator. And then finally we have g of 3, so that's 1/8 to the third power, which is 1 to the third over 8 to the third, which is 1/512. Pause this whenever you need to. We're going to take a look at some graphing review questions here. If you missed the graphing, because you have several of those questions in your homework set 19. So I am graphing 3 to the x minus 2. We'll talk about that here in a second. So largely, I think a good idea is to use x values of like -2 to +2. You want to graph 5, maybe 6 points so that you can see how it like goes up or down exponentially. All right. So if I plug -2 in for x, I get 3 to the negative second minus 2. If I plug -1 in for x, I get 3 to the negative first minus 2. If I plug in 0 for x, I get 3 to the 0 minus 2. If I plug in 1 for x, I get 3 to the first minus 2. If I plug in 2 for x, I get 3 squared minus 2. All right, so I want to graph -2, -17/9, -1, -5/3, and so forth. All right, so this -2 all by itself, that's the horizontal asymptote. And if we graph that, we would just see that, hey, I'm approaching -2 as I go to the left. I can't cross -2. So we want to have like a dotted line for the horizontal asymptote here in a second so that I know I am not going to go below the line y equals -2. So there's roughly -2, -17/9, -1, -5/3, 0, -1, 1, 1, 2, 7. All right, so here you can see it now really starts to go up exponentially. Okay, here not so much, but then bam, there comes a point where those y values are different by quite a lot, and you can really start to see the exponential growth. Okay, so again, a dotted line here at y equals -2. This line cannot go under it, as that is definitely the horizontal asymptote. If I had this on Desmos and I just kept going to the left forever, basically look like it's at y equals -2, but it would never go below it. All right, we're just going to continue here with some more graphs. We have 1/3 to the x. Again, it's called exponential because x is an exponent. So I'm going to plug -2 all the way to 2 in for x. 1/3 to the negative second is actually 9. 1/3 to the negative first is 3. 1/3 to the 0 is 1. 1/3 to the first is 1/3. 1/3 to the second is 1 over 1 squared over 3 squared, which is 1/9. All right, so I have decay here because if I plot my points, -2, 9, -1, 3, 0, 1, 1, 1/3, and 2, 1/9, it starts to go south. Now, notice I didn't have a number that I was adding, so it's really +0. So that's the horizontal asymptote, y equals 0, where y equals 0 is the x-axis. So this graph will never go below the x-axis, all right? So it's just going to hug it really forever. Okay, not trying to make a very, very long video, so pause this whenever you need to. Now I have x minus 2. X minus 2 as an exponent. all right? So I'm not going to use negative 2 to 2 because if I plug negative 2 in for x, I'm going to have 2 to the negative 4th. That's a bit much. So I still like that negative second power, so I'm starting with 0. All right, I went 0 through 5, so I'm actually plotting 6 points here, okay? So if I plug 0 in for x, I get 2 to the negative second plus 1. If I plug 1 in for x, I get 2 to the negative first plus 1. If I plug 2 in for x, I get 2 to the 0 plus 1. If I plug in 3 for x, I get 2 to the first plus 1. If I plug in 4 for x, I get 2 squared plus 1. If I plug in 5 for x, I get 2 to the third plus 1. My horizontal asymptote is y equals 1. All right, so I'm not going to have a point go below y equals 1. And if I plot those points, 0, 5 fourths, 1, 1 1/2, 2, 2. So again, like it basically looks like a straight line. Then 3, 3. Now it's looking a little more exponential. I could probably stop there, but like this right here in between, that's when it really starts to kind of explode there, really go up. All right, that's why I wanted to put the other one. Okay, so you can see kind of the curve it makes, an exponential curve that we see there. Again, pause this if you need to, wherever. So this is on your homework set 19, it says like, give me the tables. This is what I want to see. I want to see that. If you simply give me the graph with no table, you're not getting credit. All right, that is a clear cut. I looked at homie's answers. All right, 1/2 to the x plus 1, so I got a plus 0. That would be my horizontal asymptote, y equals 0. Y equals 0 is the x-axis. So I'm going to plug negative 2 in for x. That's fine. Negative 1, 0, 1, and 2. If I plug negative 2 in for x, I get 1/2 to the negative first. If I plug in negative 1 for x, I get 1/2 to the 0. If I plug in 0, I get 1/2 to the first, and so forth. All right? And those are my y values. Remember, f of x is the same thing as y. So I'm going to plot these, negative 2, 2, negative 1, 1, 0, 1 1/2, 1 and a comma, a quarter, 2 and an eighth. All right, so if I plot those, there it is. If I plugged negative 3 in for x, that might have been a good idea. If I plugged negative 3 in for x, I would get 4. So, then it would really, you would see it from the left side there. All right. We have one more, possibly. That might be it. Let's see. That is it. Instead for 6 here, because this was the first page on my notes. Section 9.2 logs. So this is not anything new for us. We've talked about logs. So y is equal to log base a of x. IFF, no, that is not a spelling error. IFF means if and only if. If and only if. If you see this next year or any other class, if and only if. Remember we said WRT, that means with respect to. IFF, if and only if. X is equal to a to the y power. Remember, this is the base, this is the exponent, this is what we call the answer. So a, the base, has to be bigger than 0. A can't be 1. A base of 1 is silly. And then x has to be bigger than 0 as well. If your base is bigger than 0, y can be any exponent, then your answer, x, would have to be bigger than 0. So those are the stipulations. All right, we've done a little bit with logs. We're going to make them a little bit more complicated here. It's in the year. So we have 2 equations that we are going to solve to finish. Solve each equation. Log base x of 8 over 27 equals 3. That means 3 is x is the base, 3 is the exponent, and 8 over 27 is what we call our answer. So, how do we solve this? So we want to look here. I mean, yeah, you could take the cubed root, right? You could take the cubed root of 8 over 27. That's one thing. Like, what's the cubed root of 8? 2. What's the cubed root of 27? 3. You can also rewrite it like this because 8 is 2 to the third. 27 is 3 to the third. So there's a few different ways to get 2/3 as an answer. So some of you might want to do this. I'm going to take the cubed root of 8. I'm going to take the cubed root of 27. and that gives you 2/3. That works as well. This one's a little quicker here. Number 2, a little more straightforward. Log base 4 of x is equal to 5/2. 4 to the 5/2 power is equal to x. So again, how do I do this by hand? 4 to the 2nd power. I'll take the square root of 4, which is 2, then 2 to the 5th. 2 to the 5th is 32. And that is my answer. And folks, that is my video. We're going to pick up with this next Monday, the 28th. This is Yak Math Videos, signing out.